The nervous system.
What part of it?
We're also going to be, well, we're breaking it down into, we'll eventually get to like the reflex arc. We're going to talk about, we're going to start off with the central nerve, or the nervous system as a broad overview, functionally and structurally what's part of it, and then we'll break it down into individual pieces where the different portions come. Do a whole mind blank. Sorry.
It is not possible for you guys to know too much about the ANS.
Nope.
There we go.
So, I'll give everybody a hint to start with. We've got the central nervous system. How do we break it down from there?
Autonomic, somatic, or parasympathetic or sympathetic.
Okay, so we got parasympathetic. And it breaks down into what? No. This is all encompassing here.
Autonomic and somatic.
Alright, so you got
Bam.
somatic and you've got autonomic. How do you break it down even further than that?
Somatic is just skeletal muscle.
Wait, so parasympathetic isn't broken down into somatic and
The
autonomic.
central nervous system
Should be
The central nervous system is
is
broken down.
auto and somatic,
Okay.
and then the
Yeah.
parasympathetic and
Okay,
sympathetic
fantastic,
is
thank you.
underneath
Huh?
auto.
Thought I would be able to teach you.
I'm letting the
right.
students leave this, right? Leave this, right? Alright, so let's start over. What is it?
CNS is broken down into somatic and autonomic.
Okay, thank you. Somatic and autonomic. Which one does afferent, which one does efferent?
Auto is not controlled by you, and somatic is volume.
Skeletal muscle.
One of the ways that I remember this is, it's the same. Somatic is an afferent nervous system. The motors are, or the autonomics are the efferent system. If that helps anybody out, it helps me out.
You can also think afferent arrive, efferent exit.
That's
how I remember.
I like that
End
one.
of mnemonic.
And then we break down further how.
Auto is yes, yeah.
So you got what?
Sympathetic and parasympathetic.
Sympathetic and parasympathetic. Huh? Does this make sense to anybody? Does this
Yes.
have any confusion here for anybody?
No.
Don't say those words.
Right, here. Or who's up, who's up next?
Alright, let's start with sympathetic. Sympathetic also is called the thoracolumbar system because the nerves are coming from the thoracic and the lumbar. The parasympathetic is also called craniosacral because the nerves are coming from your cranial and your sacral area. The nerves that are coming from the sympathetic, the one thing about them is that their ganglion are closer to the spinal cord, and then the postganglion is closer to the organ. The preganglion for the parasympathetic is closer to the organ. Yeah. So the sympathetic or the preganglionic for the sympathetic releases acetylcholine, and then on the postganglionic it releases closer to the organ releases norepinephrine. The thing about do you want to take over? The thing about sympathetic system is it also releases signal to the adrenal medulla, which also releases norepinephrine that helps with the system.
Epinephrine.
Both.
But mostly epinephrine, I think.
Okay, epinephrine. And the preganglionic, most of it releases acetylcholine.
Okay, yes. Let's see. Adrenergic receptors mean what?
Adrenoreceptors? Adrenal. We're talking about like epinephrine receptors?
Yeah. No, this is stuff that I learned. What was that? In the past few months. Adrenergic and cholinergic receptors. What are those? What do they?
The neurotransmitters for norepinephrine?
They receive which nerve? So adrenergic receives which? Or open for which?
Epi? You're talking about
Epinephrine or norepinephrine.
or norepinephrine?
Yeah. And then cholinergic open for acetylcholine. Yeah. So you guys understand that both. So the preganglionic is, so it's like axons, right? And then they're connecting in the ganglion. So you have preganglionic axons and you have postganglionic axons for both parasympathetic and for sympathetic. And so the neurotransmitters for both are, you guys know? Acetylcholine, which is confusing because sympathetic, we always think of epinephrine and norepinephrine, but with pre-ganglionic, before it reaches the ganglion, for both, they're gonna be acetylcholine. And then for sympathetic, that's when the, those IVs, man, I'm still like, not great. Okay, so then there's the axons that go from the ganglion and the sympathetic ganglion, and they will go to the target organ. And those are then, they're gonna talk to what type of receptors on the target organ. It's not cholinergic, it's gonna be adrenergic, because it's releasing epinephrine or norepinephrine. So my understanding is that most epinephrine comes from the adrenal medulla, which is what type of an organ? Yeah, so it releases hormones. And so it actually synapses with, it's almost like we have a sympathetic ganglion in the adrenal medulla. So it's like, it's one of these, basically. And then it stimulates cells inside of it to release epinephrine. Make sense? I think that's all.
The hormonal epinephrine or the neurotransmitter?
It's hormonal, because norepinephrine or epinephrine,
Could be
the
both.
only, yes, it could be a hormone and a neurotransmitter. The only time it's neurotransmitter if it's coming from the spinal cord or your system, and the only time it's hormone is when it's coming from your organ, which is the adrenal fluid.
Yeah.
And then the receptors, what are they called? The adrenergic receptors that respond to epinephrine and norepinephrine. What are they called?
Beta 1, beta 2.
Yeah, or muscarinic and nicotinic.
Nicotinic.
Nicotine. Yeah, that. Right.
Okay, so just to bring it home, we're gonna talk about what the heck a ganglion is, because we're gonna then talk about myelination. Okay, so when you're talking about the preganglion and postganglion, essentially what we're talking about is a nerve cell that has its cell body and a collection of cell bodies forming a ganglion. And when we listened last week, we know that this is where there's like all the little dendrites and they're all synapsing, doing their communication thing. And coming away from that is the axon tails, right? And that's what forms what most people think of as your like nerve tract, right? When you envision a nerve, it's like long and it can extend a wide distance. You're thinking of the tract that comes away from your ganglion, your cell body. And when we talk about these what the heck? You just talked about them for
Conversations from axon to axon.
yeah, when you're talking about that, when you're talking about where your receptors are at, your receptors are on these dendritic bodies. They're in your ganglion. Or they are on your target organ. And that's how you communicate from one cell to a target organ. So in the sympathetic system, we're talking about our fight, flight, and yes? When you're talking about your sympathetic system, you are talking about your nerves coming from your brain, and it's going to have its preganglion. Let me see my picture. You're going to see your spinal column, and you're going to have a signal that comes in the back of your spinal cord and is sent out to your body through the front of your spinal column. That's how your nerves send out, and that's your paravertebral column. And it forms this nice little chain called your sympathetic chain ganglia, which is that collection of cell bodies, because in your sympathetic system, all of those preganglionic nerve tracts are all very, very short. And they're very, very short and they're very fast. They have the myelin sheaths on them. And that's what makes your signals really, really fast, but then very, very slow post-ganglionic because they're
Myelinated.
Oh, yay, hooray. And we talked about that last week, how we were like, oh, you get really, really scared, but it takes a second for your heart to beat really fast. That's because the long chain is unmyelinated and the short preganglion is myelinated. Oh, yay, hooray, we're going to talk about parasympathetic now, which dear precious Beatrice already told us. It has the long preganglionic fibers, ganglion real close to its target organ, and then a really short section over here.
That's unmyelinated, right? Is that what you're talking about?
Yeah, it is. That's what I am talking about. This is unmyelinated. This is myelinated. Okay, and I was watching YouTube about this earlier because preparation, and something that I found really interesting was this signal can be myelinated and can be really, really fast. And so when you have that fight or flight response, not only is it cueing your sympathetic system, but it's also the turning off of your parasympathetic system. And since your body is in constant battle between fight or flight and rest and digest and feed and breathe nonsense, just inhibiting really quickly your feed and breathe allows what signals are happening for your sympathetic system to suddenly have an impact as well. Which also, if you did your medications list, this is why we give a duo neb of a sympathetic albuterol. It bronchiodilates, that's a sympathetic response, but that's why we also give Atrovent, which inhibits bronchial constriction, and that helps make your patient breathe. Anyway, what were we talking about? Yeah, so this is myelinated, it's long, myelinated, but short, simply. We talked about ganglion.
Reflex arc. Reflex arc.
Yeah, so we also have reflex arcs. They happen. I'm going to paint with a real broad brush, and I'm sure it will be a wonderful exploration where we can talk about it much further. But essentially, a reflex arc is a programmed response that your body has in its spinal column, so that when your motor neurons, which are not autonomic, they are somatic, they are myelinated for quick response. This is how you can have the extensor flexor response of you feel something, or the withdrawal reflex where you feel something really hot, and before you've even had the chance to fight or flight, sweat or not sweat, dilate your pupils or not dilate them, your motor neurons have already decided that they are going to withdraw. And then you can worry about, the emotional trauma of having your hand on something hot later as your body processes it. But in your central nervous system, there's a pre-programmed arc. And yes, I'm going to stop talking now so that I do not say anything that is inherent emphatically wrong. I know.
Thank you.
Do we have questions? Yeah.
So going off of the reflex arc thing,
Yikes.
I'm kind of so I'm curious what the difference is between if you touch something really hot versus someone grabs your finger and they sneak up behind you or whatever and scare you and you jump.
Mm-hmm.
Is that your muscle, or is it first going to your brain and then?
So it's yes. So key distinction is that it's not traveling all the way to your brain. Secondly,
What if it was a noise?
The known withdraw, like as this example, it's not as though your spinal column has programmed one go-to response. All fear results in this motion, right? That's not how life works. And so there are other factors in deciding what parts of your body are extending or flexing to prevent whatever injury is done. So you hear a loud noise behind you, your body might move you forward. That would be your automatic response. For you, it might be a hop, I don't know. Perhaps you take off running. But that would be a muscle response. And then the other autonomic, so that's somatic. The autonomic response to that would be then you hear a loud noise and your heart starts racing. That's where your autonomic system comes in. Both the inhibition of your parasympathetic quickly, preventing your heart from slowing down, and the engagement of your sympathetic that takes a little longer to actively speed your heart rate up. Does that answer your question?
So your response is, whatever your response is, the reflex arc is roughly the same. So if you have a signal that comes in, it's immediately going to go back out to whatever those.
So it doesn't have to be pain.
It doesn't have to be pain. No, it can be a sensory. This can be a sensory reception or a sensory response. So if you have a signal that comes into the spinal cord, it's going to split. Think of it as a bifurcation in a freeway, right? It comes in here, and then you have two motorcycles. One's going to come down here and go back to the response to where you're going to pull your hand away or jump and run. Whereas secondary system is now going to travel to the brain and say, oh, hey, something just happened. I'm going to start engaging the rest of the body to start counteracting that. All right, so you have two different responses. You're going to have the initial instantaneous, and then you're going to have that couple milliseconds later as it goes to the brain for the recognition piece, and the additional responses from there.
And it's not, pain is a distinct perception of your brain. That is nociceptors acting, I hope to God I said that right. Receptors, that signal a pain response. But you could also have like certain amounts of pressure that indicate that is a pressure type of pain, and that would be a combination of different receptors. So the fact that you hear a loud noise and it motivates you to be frightened would not indicate the initiation of that of nociceptors. Nociceptors?
Noise.
Noise.
You're talking about the pain ones?
Yeah.
Isn't it Nora? Something like
But
that.
you
I knew what you
got
were
what I
talking
was
about.
saying.
Exactly. That's all that matters.
Awesome. So yeah, it doesn't have to be initiated specifically by those types of receptors.
Yeah, like when you go to the doctor and they count in your knee and then you automatically extend. It's like a stretch reflex. And so like when your tendons stretch too far, they automatically go back. That's what you kick. And if you don't think about it, just have it real quick in your spine. It's sent right back out.
Any other questions?
I don't at all understand the afferent efferent thing.
Yeah, that'd be good.
Yes.
By afferent, efferent, are you saying voluntary or involuntary?
No, it's the way messages are received. They're either coming in to be received or they're going out to affect peripheral tissue or muscles or organs or right?
And the S stands for somatic?
Sensory.
Oh.
Sensory and motor. Sensory are afferent.
Coming in,
Motor are efferent.
going out.
Great, I understand that. I didn't understand how it was being related to these systems.
I think it's a way for us to talk about the direction in which signals are coming into the body. So when we're talking about things arriving in your dorsal portion of your vertebral column, that would be your afferent. And as it exits and leaves to send a signal, that is your efferent nerve. In the cycle of things.
So what I heard, correct me if I'm wrong, what I heard, and I don't remember which one was which, but what I heard was that one of them was related to the somatic system, and one of them was related to the autonomic nervous system.
Well,
That's what I heard, and I don't know if I heard it correctly or if I'm just not understanding what you said.
so with the somatic system where it's voluntary, those are always going to be motor nerves, right? It's voluntary, they're always going to be moving something. It's skeletal in nature, but for the autonomic system, you can have sensory information perceived, and then you can also send out your efferent signal to stimulate autonomic systems like pupillary constriction or dilation.
There's not one system that only receives information and one system that only sends out information, I think.
So both
Systems are sending and receiving information all the time. Is that kind of what you were confused about, or it sounded like you said?
I am confused about that.
I think
I
I'm
don't like
confused
that.
about
So-
that because I just explained the opposite of what I said. Here you go.
I don't know, well, all I remember is that there's the this is not the first, but here's, every vertebra has the afferent and efferent is just, all it is communication, whether it's coming into or leaving. But our way of perceiving information, our way of we can have cells, I'm just talking out of my ass right now a little bit, so you guys have
You're killing
information.
it. Keep going.
Okay, but so the heart can send and receive signals, cells within the heart, as in cells throughout our body, so we're not gonna have things that only send information and not receive
Okay, so,
No?
it's getting better, I'm clearing up a little bit.
Okay, so I think my understanding of
So what is an efferent signal and what is an efferent signal?
okay, how about this? And I'm not sure which one's dorsal or ventral or whatever, but let's say.
Top is dorsal.
Okay. Well, no, let's not do that. I don't remember which one's which one's that.
It's like hold right here. It's right here. I got you. This one's efferent. It's dorsal. This one's efferent.
And after it goes out?
No.
Yeah.
Arise.
Arise. Okay, so there are axons then, so these are gonna be axons that are traveling this way on the afferent, because it's receiving that, sending that information from the hand that got burned. That's the flame and the hand. And so it's sending the information here to send it back to the brain. And the efferent, so those messages come in through one part of the vertebra, and then the efferent leave from another part of the vertebra. That's,
Which the efferent signals do.
they, for example, would have axons that go to the ganglia that then that synapse in the ganglia that then send signals to the target organs.
Or back to the brain, it's nerve sensory.
That would be afferent coming.
So you're saying the afferent ones are essentially coming, to simplify yours, are coming from the brain and
No.
Afferent
Is-
is coming from the peripheral
Afferent goes from out
systems.
to in.
So hands and feet, okay? And
Is that afferent where it burns and the efferent is making it move because it was burned?
Yeah.
And that's your reflex arc. So you have your
Yes.
afferent will go, you have your signal from your target problem per se. I burn my hand. I have an afferent signal that goes into the
it's
spinal cord.
received here.
And then the efferent signal goes back out for the response. Or else the afferent goes up to the brain, and then the efferent will come back out.
And
Those are
that's-
kind of the highways that he was talking about, where it can go. the brain or back out.
Does it go to both?
And that's not an or,
Yeah,
that's an
so-
and. It is happening. You have.
Excuse me, you guys.
You have, that's not a question of either or, either you do your extensor, flexor, or whatever. You are both doing that and sending the signal up to the brain because you will eventually think about it.
Not only think about it, but your pupils will need to dilate, or you will need to activate skeletal muscle to have a
Yes.
physical reaction, or have epinephrine pumped to different parts of your body so that they'll either, so that they can be
And then
active.
medieval oblongata is gonna be like, oh, the arm's up there now.
Yes, sure, that's great.
So the afferent and the efferent are nerves that receive information and then either go to the brain or to the body system, are the peripheral nerves.
Here's the vertebra,
Right.
and so every single one of these has afferent and efferent pathways.
And those pathways are nerves.
Yeah.
Okay.
And nerves have many axons. And so these will, for example, the efferent are going to the ganglion, which is where the somas, which has all the information like the cell bodies are. And you can have, so they're like all in the ganglion and they can go from different places, right? From here.
Mhm.
So then that's going to a target organ over here, this is going to a different target organ. And so it's sending, basically like I think of it as if we're gonna send neurotransmitters, they have to be facing the same direction, right? So the efferent are making sure that those neurotransmitters are facing this way so they can go out to the peripheral body. Whereas the afferent are making sure that the dendrites are on one side and the axons are on the other side and they're facing towards the vertebra to send the messages towards the vertebra.
Okay.
So they're just pathways.
And from this, your nerves are going to go through, they're gonna conjoin at some point, and that direction that Swofford was talking about is maintained. However, it's gonna go through a chain along your spine called your paravertebral column that runs along your spine, and there's a multitude of different nerves that either synapse here or they bypass that and go down to their target organ. What kind of nerve do we think that would be? Parasympathetic nerve, because it's innervated close to the target organ. Yeah, that's right. I mean, you get what I'm saying, right? Like, it's gonna synapse close to the target organ, so we know that it is parasympathetic.
I thought you said sympathetic was close.
Yeah.
I thought you said that before. We said sympathetic,
Yeah.
the ganglion, and then the second
True right here.
post-ganglionic nerve is right next to the target organ, was for what you said, sympathetic.
No.
No.
Parasympathetic.
No? Okay, parasympathetic.
So right
Parasympathetic.
here. Parasympathetic has the long and then the short close to the organ. The ganglion is close to the target organ, whereas this isn't very long right here, but anyway, this is supposed to be out here.
But the
I have a question.
post-ganglionic nerve is a lot longer and sympathetic
Yes,
from the organ to.
yes,
From the ganglion to the organ, yes, it's longer.
yes. It's really
Ganglion,
long.
I have a question though. Do ganglion only have sympathetic cell bodies in them or parasympathetic cell bodies?
Can you,
As I'm thinking about this.
Name the parasympathetic system. Anatomically name it. Answer the question. What is the
Oh,
anatomical
the
name of the
thoraco.
system?
So all
So what do you
the ganglions
Yes.
from parasympathetic are coming just from the nerves and the sacral area. So the number one nerve that parasympathetic controls is the vagus
Vagal.
nerve.
Yeah.
So that,
Which comes out of what?
the brain, which is number 10.
10, number 10.
Number 10, and it goes straight down through and to the rest of your internal
Does it go
organs.
through any of the paravertebral ganglia or the prevertebral ganglia?
No,
Does it go through any of the? 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 Does
I'm sorry.
No, because they're so far
So
away.
does the vagus nerve at any point in time travel through either the paravertebral ganglia or the prevertebral ganglia?
I was thinking it was going straight to the organ. That's
So
my
are
understanding.
there any parasympathetic postganglionic neuron bodies in the paravertebral column or the prevertebral column?
No. And we know that because we worked on intubation the other day, / today, this morning. And when we talked about intubating children and accidentally vaguely stimulating them, when you go to put in your laryngoscope, that's because you're touching, you're not really touching, but like you're putting pressure on the vagus nerve. And you wouldn't be able to do that if it were running down your paravertebral column, right?
I like that. I didn't know that.
Thank you, Leonard.
Me and Matt skipped in the first class.
So,
Think about it later.
so I'm unclear on what our neurotransmitters and receptors are and where those neurotransmitters and receptors are found. Let's just start with one system, the parasympathetic system. What neurotransmitters and receptors are we dealing with the parasympathetic nervous system?
Oh, you want, no, you should.
Get it, girl.
I mean, straight answer, pre-ganglion and post-ganglion both are acetylcholine.
For the parasympathetic system?
Yes.
What receptors are we talking about? And where are those receptors at?
So. The receptors are cholinergic and muscarinic, or, yeah. Wait, what were they again?
What are the receptors?
Cholinergic receptors and muscarinic.
What are,
So
what are
cholinergic-
cholinergic receptors?
They receive acetylcholine as their messenger.
And how many types?
They
are there?
open with acetylcholine.
And how many types are there?
Two.
And what are those types?
Muscarinic and this.
Nicotinic.
So where are those receptors found?
Nicotinic.
So where are those receptors found?
Wouldn't they be on,
The organs.
yeah,
I think.
I think I found it on my phone.
well, they could be on anything. They can be on axons. They could be in the dendrites of axons.
I want to know which specific receptors are found where, not generally speaking. I want to know which receptors we're talking about and where they're at. So the parasympathetic system,
There's an
Has-
acetylcholine, there is one on skeletal muscle, as we learned.
does the parasympathetic system activate the skeletal muscle?
No,
So that's not one we're talking about, right?
no.
So
But I'd like to remember.
where are the receptors found for the parasympathetic nervous system?
So you said, what was the M1 called?
Muscarinic and nicotinic. Nicotinic.
So, I really hope I'm doing this right.
So is there no cholinergic?
Okay, well, let's like think through it. So my thought process is that they are on synapses between neurons, and they are also on target organs. And I think that
Which ones are where?
Okay, acetylcholine is in,
The muscarinic one says they're the one that are actually on this target organ, so in
so
this case,
here's
cardiac. or-
acetylcholine, and then it goes in vesicles.
What axon is that you just drew? What
That is a, what axon is it? That's, yes. Yeah. Well, it's a parasympathetic axon. Well, actually, it could be both, but he's asking for parasympathetic. It goes in a vesicle. That vesicle is
What
spit out
neuron is
into the
that?
synapse.
What neuron is that you just drew?
Is it pre or post ganglion? It wouldn't matter for parasympathetic because acetylcholine is the neurotransmitter for both.
But what,
What neuron?
What
What's one
receptor?
thing that we could be stimulating, sending an for parasympathetic?
let's make it easy. Let's
To
say
your
you're
eyeballs.
gonna draw the vagus system, all the way down to an
One
effector
nerve.
organ.
Okay.
So.
I mean, kidneys has sympathetic stimulation. A kidney has both. Kidneys have both. Yeah. I know. What's that
Anyone
about?
else?
There's.
Is it muscarinic?
So you're talking about which receptor is on like the actual target organ?
Here's a target organ.
Target organ.
What's
So
a
we're-
parasympathetic target organ that could receive a message?
Heart. So it
But
says
we're
it's
not-
the
he doesn't want us
mus.
to do muscle.
I don't care about muscle.
So
I don't know.
So it's the heart.
Okay, so this is the heart. This is a muscarinic receptor.
Oh,
I think it's M1.
mine says M2. Maybe I'm wrong.
Excellent.
I'm okay with you not knowing the subcategories just yet.
Okay.
Muscle
Yeah,
is
we'll have
perfectly
to-
fine for right
That's
now.
true.
Okay. And here's a nicotinic.
That is on the target organ.
So you've drawn both a nicotinic and a muscarinic on the heart,
Okay, I
is that
don't know.
correct?
I think it's.
I'm just asking what you're meaning to draw, not whether it's right or wrong.
I don't know. I'm
Somebody
happy
else?
to, I'm happy to draw this. from
Those,
Yeah, it's
and
only-
the other one is the one you were talking about with like the adrenoreceptors for your norepinephrine for your sympathetic.
No. Nicotinic is?
No, so so M1 is your acetylcholine for your.
Oh, you're saying the other
parasympathetic.
one would be like a beta
Yes,
1 receptor?
yes.
For the
Okay.
For
parasympathetic system?
the sympathetic nervous system.
For the organ, for the target organ.
We're on the parasympathetic system.
Yes.
Oh, my
Beta
bad. I
is
was
not
doing this-
part of
Okay,
it.
let's just stick with M1.
So muscarinic.
So acetylcholine comes
My
and
bad.
it opens it so that whatever it is that needs to come in here can.
I'm still lost.
I don't think you're wrong.
I don't think you're wrong either.
On a target organ of the parasympathetic.
Well, but there's no one, I don't,
Muscarinic is what you're saying.
That's what they're saying. Do you agree?
We got that part covered.
I don't know that we agree. I would be.
I agree.
Because that's the organ, not continuing
Target organ of the
on the
parasympathetic
nerves.
system is muscarinic. Okay,
Yeah.
what about the sympathetic system?
Wait, are we
Not
done
that
with
we're-
Wait,
parasympathetic?
how about the
Okay.
stomach?
Okay.
We know the.
We're not done with parasympathetic?
I was like, we're not done yet.
That's the route I was going.
Okay, wait, pause, really quick. So, can you repeat your question?
Yes.
Okay.
I want to know what neurotransmitters and what receptors are being activated in the parasympathetic system and where they're found.
Okay,
Here's the neurotransmitter.
so we have our neurotransmitter of acetylcholine. It is always excitatory, and it's two types of receptors are muscarinic and nicotinic, which are umbrella term cholinergic receptors, and you can also find them on the target organ themselves.
Both of them?
Both of what?
Nicotinic and muscarinic?
Yes.
I'm guessing, yeah.
Is that true?
I don't think so.
I don't
I would guess
No,
it's
I don't
not.
think so.
I don't think
What do you think, Amanda?
I think nicotinic receptors, if we're not talking about the vagus nerve, I think nicotinic receptors receive acetylcholine between the pre and post ganglion.
Oh.
That is my guess, and I think muscarinic,
The nicotinic?
yes.
Okay, so
I
this would be
think
a
muscarinic receives the acetylcholine on the target organ.
Thank you. That sounds really reasonable.
That would also make sense because nicotinic receptors are named after nicotine, which is one of the few chemicals that can transcend the blood-brain barrier. And so if it's pre, that means it would be have access to that area. You know what I'm saying? It works for me. Great. Moving on.
We all agree or disagree?
That sounds right.
Used yet?
I was like, my brain was looking for a while.
Okay, so my follow-up question to you guys is you're confused right here, and some of you are sitting there wondering, what the hell does this have to do with paramedic? And I say to you, where does atropine work? Where does atropine work? Where do these drugs work to get the effect that we want? And where don't they work?
They're gonna block
Why
the.
does nicotine do to the body what it does? And why do people who initially start smoking nicotine have one effect, but people who have been taking nicotine for a long time have a different effect? And why would our patients be different if they have some sort of affliction while also being a new smoker versus a, I don't know,
Chain
40
smoking hack.
pack, yeah, 40-year pack, whatever smoker,
I can say that
right?
exactly.
So where these receptors are and where these chemicals work becomes very important. So I'll leave you with this, and you have some work to do, okay? The cell body, I'm talking about the parasympathetic system only. The parasympathetic system only right now. In order for the parasympathetic system to engage its target organ, it has to go through what we call neurons in series. There are two of them. We've named them preganglionic and postganglionic. That's the name of them. Sometimes they're referred to as presynaptic neurons and postsynaptic neurons. It means the same thing. So if we want our heart to have a parasympathetic effect, a signal has to travel down two peripheral neurons within the vagus nerve. Let's say I want the heart to slow down. My medulla oblongata, the cardiac center in the medulla oblongata, is going to initiate a signal in the presynaptic neuron of the vagus nerve that has a very, very, very long myelinated axon. That long myelinated axon is going to travel out of my cranium, cranial nerve 10, is going to travel down my body and into the wall of my heart. It's that long. The vagus nerve is ridiculously long. We have some motor neurons longer, but it's a ridiculously long nerve. That is a preganglion, a presynaptic neuron. It is going to release acetylcholine, and that acetylcholine is going to travel across the synaptic gap to the postsynaptic neuron of the parasympathetic system. We're not at the target organ yet. We're still within the series of neurons, yes? That acetylcholine is going to activate a nicotinic receptor on the postsynaptic neuron that is a tiny, small little neuron within the wall of the vessel. We good so far? Yes. Nicotinic receptors almost always activate channels. It's going to be different from what I'm about to say. They almost always activate channels. When the nicotinic receptor on the postsynaptic neuron is activated, a sodium channel is going to open, and sodium is going to flood that second neuron. Good? If that second neuron is flooded to the point of the trigger zone being activated, then it'll finish a signal to the end of that, the axon terminal of the second neuron, where once again there is more acetylcholine in the vesicles. And that acetylcholine is going to also be released from the postsynaptic neuron. But now the synapse is between the second nerve, the second neuron, and the actual organ itself. Good? Those receptors are muscarinic receptors. They are not channels. They are what we call G-protein coupled receptors. We'll talk about G-protein coupled receptors in another class. That G-protein coupled receptor is going to initiate a second messenger system that will cause the heart to slow down.
The camp thing?
What's that?
The camp?
Then it'll activate cyclic AMP.
Yeah.
So we have acetylcholine being released from the presynaptic neuron onto nicotinic receptors of the postsynaptic neuron, leading to acetylcholine being released from the postsynaptic neuron, the second neuron, onto the effector organ itself, where it's engaging muscarinic receptors. Atropine and Atrovent are very similar drugs, and both of them are muscarinic blockers. They don't do anything to nicotinic receptors. They only activate, in this case, deactivate muscarinic receptors.
So it's going to take away the parasympathetic system on the target organ.
Nicotinic receptors are almost
It's going to take away the
activating
muscarinic on the
opening
target
channel.
organ.
Okay.
Muscarinic receptors are all G-protein coupled receptors, which we will discuss what a G-protein coupled receptor is later, but they're not channels. They're not channels. Things don't open with muscarinic receptors. Instead, muscarinic receptor activation causes chemical reactions within the cell. That's different than opening a channel.
So when we give atropine and Atrovent, we'll still have the parasympathetic signals going down and targeting the nicotinic receptors. Those signals are still plugging in and releasing acetylcholine, but when they get down to the muscarinic receptor on the organ and they release, that muscarinic receptor is blocked by the atropine and Atrovent so that it doesn't engage
That is
and
correct.
it doesn't bring the parasympathetic down, for the heart rate to go down or for the lungs to constrict,
That
and the
is correct.
sympathetic takes over to open it up.
That's correct. We are not stopping the parasympathetic system activation. We are blocking
At the target
it
organ.
at the target organ. That's correct.
And all those muscarinic receptors are the same on target organs? Is that a true statement? Is the muscarinic receptor on the heart the same